Let's take a look at example number 6 here. IQ tests are sometimes used to measure a person's intellectual capacity at a particular time. Now, IQ tests are based on a mean or based on a normal, and they are normally distributed, and there is a mean of 100 and a standard deviation of 15. Now, if a person scores 119 on an IQ test, how does this score compare with scores of the general population? When we're talking the general population, we're talking kind of where does a person's intellectual ability stand? Now, in this case here, we're given a we're given a data point, a mean, and a standard deviation, which means that we need to solve for what is the Z-score for this population. Okay. Now, if we know that, let's quickly get a couple of numbers in here. Okay, so we're going to put them in here. We have 100 is our mean. I'm going to put that in there. And that means that 115 is one standard deviation and 130, and this is going to kind of cover what we really need to know here. 145 is right there. 119 is going to fit in right about here. Okay, this will be about 119 right there. Okay, there's our line 119, and I'll put that in as well. And we want to figure out how does this one fit in according to the normal population. What we're going to first find, given our Z-score and then the probability, is what percentage of people fit underneath. So how do they fit in the Z-score? How do they fit in underneath? And the second, I want to also find how do they fit above. Okay, so what is above the Z-score? And we'll do both of those in this case here. So first things first, we need to find the Z-score for this population. Oops, okay. So Z-score formula, Z is equal to X minus X bar. Bar going there. Bracket over sigma. There we go. And so to solve for Z-score, we plug in our values that we know. Z is equal to 119 minus 100 divided by a standard deviation of 15. Now there's no units on this, and so in this case here, we're just left exactly there. And we're going to get Z is equal to, and I'm going to use a calculator for this here, 119 minus 100 gives us 19. Okay, so it gives us 19. And then we divide that by 15, and we get a Z-score of 1.27. Let's round it up. It's 1.26 repeated, so we round it to 1.27. Now, go to our Z-score table. We're going to look at 1.27. 1.2 is right here. And 7 is right here. And look at that, we get a 0.8980. So, .8980. Okay, there's our probability, and that equals to 89.8%. Okay, so therefore, we can say that 89.8% of the population has an IQ of less than 119. And I'm just going to make this a little bit nicer here. There we go. So we can say that 89.8% of the population has an IQ of less than 119. What we can also say at the same time, so this would mean that if you have an IQ of 119, you're like pretty much have a higher IQ than 90% of the population. We can also take our other value here, or we can subtract, and this will be 10.2%. And we can say that 10.2% of the population will have an IQ of greater than 119. So it compares where they are based on what percent is less than or below, and what percent is above, okay, that IQ. So we can find both what's below and what is above that IQ. Now again, this is understandable. We just subtract it from 100, subtract percentage from 100, and we come up with our answer. But again, we have to remember that this is how we can do that. Okay, we can find both below and we can find above and figure out where they fit in according to the general population. Okay, you can say if you have a 119 IQ that you have a higher intellectual capacity than 90% of the population, but you're lower than 10% of the population. Okay, so that gives you an idea as to where you fit in that spectrum according to normal.